Hello everyone. In the last chapter we had an introduction to matrices. We saw how a matrix can translate vectors from one world to the other and can act as a bridge between different worlds. We introduced three different but related worlds: a fruit world, a box world, and a package world. Then we saw how two matrices can be used consecutively to translate a vector from package world to box world and then from box world to fruit world. But what if this problem of finding number of fruits from packages is a frequent problem I have to solve? What if I order different number of packages every day, so the package vector might change every day, but the content charts are fixed? I would like to avoid this two-step process of always going from package world to box world and then to the fruit world. Can we find a direct translation from package world to fruit world instead of going via a box world? I think in that case I will have to find out exactly how many fruits of each kind are there in each package. From the chart, you can see that package X has one box of type A, three boxes of type B, and four boxes of type C. But this looks like a vector in a box world. We can actually use the box to fruit translator now to find out the fruit combination. So what we see here is the number of fruits that are in package X. Similarly, we can find the combination of fruits in package Y. Finally, we can combine both these results and form a direct matrix from package world to fruit world. Or in our simple content chart form, we can show it as follows. Let's apply this translator on my package order 43, which we saw earlier. Oh, we got the exact same result as we had got in the last chapter, but this time in just one step. The direct translation matrix that we found is called a concatenation of the two matrices, and the operation we did to find is called a matrix-matrix multiplication. The direct translator, or the shortcut that we found from package world to the fruit world, can be shown here like this. See how it avoids going through the box world. I was talking about creating different worlds, and I see another interesting one: the one-dimensional world of money. Each fruit is worth some money, and following is the rate chart. Suppose I would like to know the worth of box A, whose fruit contents I know. Can this rate chart matrix act as a translator between four-dimensional fruit world and one-dimensional money world? Could you use the matrix vector multiplication that we saw earlier in this case? Sometimes it could be scary to look at the matrix with just one row and people don't know how to handle it. But if you keep in mind the meaning of these numbers, the problem seems trivial. So box A is worth $18, and here how it looks in the vector notation. In mathematics, the above multiplication of a vector and a matrix with just one row, which at the end gives a one-dimensional result or a simple number, is called an inner product or dot product. That's it for now. The aim of this video was to focus on the fundamentals of vectors and matrices using simple arithmetic. I hope you have got some insight into the world of matrices and are now better prepared to tackle advanced topics in linear algebra. Subscribe to Inside Diary to get more such videos. You will have to, at some point, start thinking in terms of coordinate geometry to get entry into these advanced topics, and in my opinion, the Essence of Linear Algebra series by 3 Blue 1 Brown is the best series available on the internet that does this job. So keep learning. Best of luck.